Hi, this is Paramita. In this video, I'm going to explain what is state transition testing. Okay, now state transition testing is a specification based or black box testing technique in which the tester analyzes the behavior of an application under test for different input conditions in a sequence. Okay, now what is black box testing or specification based testing? I have already discussed in my previous videos. If you want to see, you can check in my previous videos. I have clearly discussed what is black box testing. Now, so this is one type of black box testing where the tester analyzes the behavior of an application under test for different input conditions in a sequence. Okay, now I will explain this soon, like what does it mean by different input conditions and different sequence like this. Before that, I will explain why to use this. We cannot use this state transition testing technique everywhere. There are some limitations. Okay, we can use this testing technique only in some particular situation. Like number one, this can be used when a tester is testing the application for a finite set of input values. That means the how many input values we can use for testing, that's finite. It's not like infinite. Like previously I have explained the boundary value analysis and all. We use those techniques, boundary value analysis, equivalent partitioning, uh, in situations like there can be a lot of input if we want to use, so we cannot do all testing. That's why we use those testing technique like boundary value analysis and equivalence partitioning to reduce our test cases. Okay, but here the finite set of input values, that means how many input values can be there, that is finite. That means it will be very limited, not too much. Okay, so there will be some situations where the situation will be like this. There will be finite number of input values. Okay, then when the tester is trying to test sequence of events that occur in the application under test, that is, this will allow the tester to test the application behavior for a sequence of input values. That means it will be like that if you put one input value, it will go to the next state, then again next state, like this. So the events will happen in a sequence. Okay. Then, when the system under test has a dependency on the events or values in the past, the same thing which I just told, like the events will occur in sequence. Now, I'm just giving here an example to explain the thing, then it will be more clear. Suppose in the the banking login screen, consider you have to enter correct user ID and password to access the banking application. Okay, so we all use our ATM card and all, we know how it works. So it's like similar example. Now the conditions here are number one, it gives you the access to the application with correct password and login name. Number two, the application allows three attempts, and if user tries fourth attempt, the system blocks the account. Now here I will just do little correction. If user tries fourth attempt with wrong password. Okay. If user tries a fourth time with wrong password, the system blocks the account. Alright, so see here I have created, this one is called state transition chart, the top one. And this is called state transition diagram. Both explains the same scenarios. Now here, see, there are three parts in the state transition diagram or state transition chart in both, there are three main components. Okay, the first one is states. There are different states. Okay, and the second one is state transition, and then events and action. So four components actually. Okay, now here see, in the state transition chart in the left bar, we have shown all these are different states. Like here in the diagram, see, S1 means state 1, start. S2 means state 2, which is the first attempt. And this is S3, S4, S5, like that. Similarly, here also in the chart we have written S1, S2, then state 1, state 2, state 3, state 4, like this. And state 6 means access granted, and state 7 means account blocked. Now at the first stage, if correct password, it will go to the access, state 6. If incorrect, it will go to the second attempt. Okay, now, state 2. Now in state 2 at the first try, if correct password, S6, access granted. If wrong, we'll go to the next state, which is state 3, here, the second try. Okay, so this way, you can see here, and in the diagram also, you can see the same thing. And from one state to second state, when it's going, it's called state transition. Okay, now the event will be here, like entering correct password or entering wrong password. And the action, if you put correct password, the action will be access will be granted and your banking page will appear. So that's the action. And if you put the wrong password at fourth attempt also, which is our state 5, then you will get the message your account is blocked. That will be the action. Okay. Now depending on this diagram or on the chart, whatever you use, you can derive the scenarios, and on that basis of scenarios, we can write the test cases. Like here, see, there are different scenarios. Like here, with the first attempt, there one scenario can be user enters the correct password at first attempt. Another scenario can be user entered wrong password. Similarly, at the stage 3 also, user can enter correct password or user can enter wrong password. So in each stage, there will be these two scenarios. Okay. So if we write the scenarios like this, we can write at first attempt this, second attempt, then third, fourth, like that. Okay. I didn't write all. I just wrote the first try and then second try one. At first try, one scenario is user enters correct password and another one is user enters wrong password. Similarly, at each stage, there will be these two scenarios. Now, it depends. So there we can say that it's infinite. There are not like infinite inputs. How many inputs, how many scenarios will be there? It's quite countable. It's not like very large numbers. Okay. So that's why we can use the state transition testing here. And all the events, see, first try, second try, third try, fourth try, they depend on their previous event. If you put wrong password in first try, then only you will go to the second try. If you put wrong password at second try, then only you will reach at third try. Okay, so they depend on each other. Basically, they depend on the previous state. So all the states are happening sequentially. Now it's up to you if you want to test all the finite number of input. You can test, or if you don't have time, then you can prioritize. Now here you can see the first important test is this one at first try. If you put correct password, you should be granted access. You should reach stage 6. So this is one important, and another one important is if you put wrong password here at first attempt and then again put wrong password second attempt, again put wrong password third attempt and then fourth attempt, then you will get blocked. Okay, this is also important. But there can be another scenarios like at second attempt you put correct password and third attempt you put correct password. Those also can be some similar scenarios which we can test, but those are not so important. Or if you want, you can test one of those scenarios. Okay, don't need to test all those scenarios depending on your time and other limitations. If you want to test, you can test. If you have enough time, you can. But otherwise, you can prioritize your testing depending on the priorities. Okay, so that's how we can use state transition diagram and state transition chart to derive the scenarios and test cases. Okay, so this is a black box test testing because we can create these types of state transition diagram, chart, and the scenarios depending on some specifications only. All right. Thank you for watching.